Hello, future scientists. Are you ready to go on an adventure through the universe? Have you ever wondered why stars shine so brightly, or how a simple rubber band snaps back into shape when you stretch it? The world around us follows a set of invisible rules. These are called the laws of physics, and they shape everything we see and do. These laws are like the universe's secret codebook, helping us unlock the mysteries of everything, from the tiniest grains of sand beneath our feet to the most distant stars twinkling in the night sky. Physics is the ultimate detective story, revealing the secrets and wonders hidden in our everyday lives. Every time you drop a ball, watch a rainbow appear after a rainstorm, or see a spring bounce back, you're actually witnessing physics in action right before your eyes. Today, we'll explore 4 amazing laws that changed how we see the world and made the impossible possible. Why hot things glow, how springs stretch and store energy, where light gets its energy and how it travels across space, and the invisible forces that power our lives, from electricity in our homes to the energy that moves the planets. These discoveries made by curious minds just like yours gave us everything from glowing light bulbs to powerful rockets that reach for the stars. Are you ready to unlock the universe's biggest secrets and become a science detective? Let's start with a simple but amazing observation. Have you noticed how things change color when they get hot? This leads us to our very first law, a fascinating rule that connects color and temperature in a truly cool and surprising way. So let's begin our quest for knowledge and see what secrets the universe is waiting to share with us. Have you ever watched metal being heated in a forge, glowing first a deep red, then shifting to orange, and finally turning a brilliant yellow-white as the temperature rises higher and higher? This fascinating color change isn't just for show, it's actually a direct clue to the metal's temperature, and it's beautifully explained by a fundamental principle called Wien's displacement law. According to this law, the hotter an object gets, the shorter the wavelength of light it emits, causing its color to shift from red to blue as the temperature increases. Astronomers rely on this law to measure the temperatures of distant stars simply by observing their color. Blue stars are much hotter, while red stars are cooler in comparison. Wilhelm Wien first described this relationship in 1893, and his discovery was so important that it earned him a Nobel Prize for revealing how the colors of light can unlock the secrets of the universe. Here's a quick question for you. If you spot a red star and a blue star in the night sky, which one do you think is hotter? Remember, blue always means a higher temperature. The bluer the star, the more intensely it burns. That's the incredible power of Wien's law. It acts as a cosmic thermometer, letting us read the temperatures of stars just by looking at their colors in the night sky. Let's talk springs. Springs are everywhere around us, and they're more fascinating than you might think. Ever notice the harder you pull, the more a spring stretches? It's not just a coincidence. There's a scientific reason behind it. That's Hooke's law in action, a fundamental rule in physics that helps us understand how things stretch and compress. It says the stretch of a spring is directly related to the force you apply. Double the weight, double the stretch. This relationship is called direct proportionality. This principle is everywhere. Car suspensions, bathroom scales, trampolines, and even inside pens and toys. Springs make our daily lives smoother and safer. Robert Hooke, a brilliant 17th century scientist, discovered this rule, helping us build safer bridges, design better machines, and create smoother rides. Hooke's law shows how simple observations can lead to powerful scientific tools that shape the world around us. Now, imagine you hang a 1 kg apple and the spring stretches 2 centimeters. That's a clear, measurable effect. What if you hang a 2 kg bag instead? The force is doubled, so the stretch should double too. It'll stretch twice as much. This predictable behavior is what makes springs so useful in engineering and science. That's the magic of Hooke's law. Predictable, reliable, and everywhere. Springs are a perfect example of how physics is part of our everyday world. Let's keep exploring. Now let's dive into light and energy. For years, scientists thought energy flowed smoothly, like water, but Max Planck changed everything. He showed energy comes in tiny packets called quanta. Imagine climbing stairs, not a ramp. You can only stand on each step, not in between. That's how energy works at the smallest scales. Planck's idea explained mysteries about heat and light, launching quantum mechanics and leading to inventions like lasers and computers. He won the Nobel Prize for this revolutionary insight. So, does a light bulb release energy as a smooth stream or in tiny packets? Planck said. Tiny packets! Quantum leaps change science forever. Our final stop, Maxwell's laws, 4 rules that unite electricity and magnetism into one force, electromagnetism. Before Maxwell, these forces seemed separate. He showed moving electric charges create magnetic fields, and changing magnetic fields create electric fields. His equations revealed that light itself is an electromagnetic wave, traveling at the speed of light. Maxwell's work in the 1860s laid the foundation for radios, Wi-Fi, and all modern communication. Every text you send uses his discoveries. So, who unified electricity and magnetism? James Clerk Maxwell. And with that, our journey through these amazing laws ends. But your adventure is just beginning. Keep exploring. The universe is waiting.